Yeah, this is the topic of the presentation. My name is Przemysław Stański, and this is my first talk on any conference, game dev conference. So, yeah, wish me luck. I'm an ex-filmmaker turned game developer. In my previous profession, I co-founded a video production company. Then when the COVID hit, I started experimenting with Unreal Engine videos. And in 2021, I started at Qubit. And I'm a self-taught programmer, narrative, cinematic, and game designer. And I wear a lot of hats during the project that we're developing right now, which is Cowboy Life Simulator. And I'm a lead programmer over there with just blueprints, which is crazy. But we do have a programmer with CPP on board. So these are some of my awards. Like, it's way easier to get any award in the film industry than in game dev industry. So, and these are like indie games. If you're from Warsaw, you may have like seen some of those shots. It's Warsaw Uprising like video from a few years back. But that was then, this is now, and right, save systems. How many of you ever wrote or designed or worked with a save system in Unreal? How many of you like enjoyed that experience? All right. Yeah, perfect. I was like, because like when the save system is easy to implement, then it's like not a big deal, but it's trivial. But then you still have to solve the bugs, because like if you don't solve the bugs, then people just, it's not like try it again, it may work, but they lose progress. And if this save system is like big and exciting and it's a challenge, it's a like a challenge, then it's fun. But also when you're done with the challenge, you came up with something, then still it's a lot of just bug fixing, which is bad. So a little background about our project. Cowboy Life Simulator was a game that was developed by some other guys that at some point I think they could not deliver anything better than they did. So we took over the project. It was an Unreal Engine 4 project, and the project had 3 separate maps with like a player's farm, the town, and some mines. And like, what is Cowboy Life Simulator? I think I didn't say that. It's a mix between Stardew Valley and Red Dead Redemption. It's a cowboy game. So imagine like this medieval game, medieval dynasty, right? But on Wild West. So our goals, we wanted to deliver an open world sim crafting game. We wanted to learn Unreal Engine 5 pipelines. And we've been working on Unreal Engine 5 with World Partition on another project that we did some time ago. So we had some experience. And we wanted to design and like at least research a scalable framework for any future projects, because we knew that Unreal Engine was blowing, and people would be moving to Unreal Engine, and there will be people working in that, and games like publishers would want to develop games on Unreal Engine with all the features. And also we had an extremely modest budget, like super tight, and time constraints, really hard time constraints. So it was mission impossible. The challenges were that it's a narrative heavy sim, and it's a crafting game. So you have lots of interaction states. You could pick up stuff, you craft stuff, you do stuff constantly. The map was medium-sized, but so we could actually, we were thinking about doing just one big level with no streaming whatsoever, and just try to optimize it. But then we figured that if we want a scalable solution, then we have to think about the map as being huge. So, and crafting has to be ongoing in a game like that, right? If the crafting times are long, taking like hours of in-game time, then it has to be ongoing wherever you go. And we wanted player to be able to build more farms, more settlements, outposts everywhere on the map. But also we want those maps to unload because there are, you know, draw calls, animations, skeletals because of the animals and so on and so on. The challenge was also me. I am a lead programmer, but I only do blueprints. And World Partition, of course, this is the biggest challenge because World Partition, as you probably know, constantly loads and unloads actor if you just go around the map. So this is something that I came up with just to prove any like some point that I think that you can say that you have this actor-oriented save system that was, you know, if you ever played Half-Life, you probably had this thing that you quick save the game when the grenade was just flying towards you, and then it lands under your feet, and you spend the next half hour try to, you know, like dodge it somehow, because then your save is you know, screwed. And on the other side of the scale, you have this data-oriented, where like in Grand Theft Auto, you just wake up. When you start the game, you just wake up in your bed or somewhere out there, and the only things that are saved are, you know, data about the world, your inventory, your weapons, your money. But the world is like, you know, created anew every time. And in the middle, you have this, I guess, Assassin's Creed or Far Cry games where you can save the data, but you can also save the position of each enemies. I think in some of those games you can do that. Savior. Thank you, man. Thank you. That's Tomasz. Thank you. Woo, 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 woo. Great. So, why would the actor-oriented save system would not work in Cowboy? Because like a typical Unreal Engine programmer would say, okay, so we have a crafting station. Let's put a crafting component in that crafting station. We can put so many crafting components in different crafting stations. So we can have, you know, crafting station doing two kinds of crafting because we put those components in there. We can put that component in a cow, so it would be crafting something, I guess. But World Partition constantly unloads stuff. So when you move away, that cow would disappear, that crafting station would disappear, your crafting would be like broken, right? So how do you like do that? You can, I guess you can access World Partition and add some methods that when it unloads an actor, it saves the state and, you know, everything. But I guess that would be extremely complicated and expensive, and like most likely CPP knowledge would be necessary. And of course, if you even save that actor, it will just be saved. It would not process that. So this is something that we don't really want. We just want it to like keep processing. So what makes an actor? And this is part of our game. This is a well, and the actor is like a bunch of data, actually. So you have transform type, completion level, like crafting queue, crafting objects, and maybe some other stuff, like project dependent stuff that it's a specific thing for your own project. And like a field, because it's a farm game, so you want to place some fields. And what makes a field? It's just a transform again. It's the species of the plant and current states, the hydration, the like quality level, fertilizers, something like that. So again, it's just a bunch of data, and it's not really a lot of data, and that easily goes into a simple struct. So even if we have lots of lots of animals, lots of fields, lots of crafting stations, we can put it all in the struct in an array or in a map, and the data in an array is fast and easy to serialize. It gives a lightweight save file, which is great. So we broke down our things in the game into structs that we put somewhere, and I'm going to talk about that. So we have construction object, animal, plant, animal, home, and the animal is the longest because it's like a moving object that can have so many states. It can be hungry, thirsty, it can reach some stuff, it can be locked in the animal pen, and it can have some traits, some parents traits, because we have some inheritance mechanics. So trick number one, yeah, I will. Oh, and of course, I forgot about that. On the last slide, I will have the QR code for this presentation. So like, don't bother taking pictures. I will just give you the presentation at the end. So first trick: use maps instead of arrays if you can. If you want to have so many things that you want to search through, use maps. It's just like an array, but with unique key. So you don't have to like go through an array to look for something, but just use find, and it gives you the thing. So we needed some assumptions for the game to deliver that, and the first one was that we don't want an actor-oriented save system. Like, we don't want to save a position of each character, which would be great for easy combat. That okay, I killed that guy, now I save. Let's kill another guy. But we are fine with a GTA style game where you just start the game and you wake up in your bed and the whole state is saved. You just continue playing. We don't want players to save and load game like I described. We want the economy to be tight and robust. Like, we want player to be able to go to the forest, pick up some stuff, go somewhere else and get back to the forest, and the things that he picked up are no longer there. I mean, they don't just respawn. We can control how much resources get into the loop of the economy, and we want all this while World Partition is constantly loading and unloading actors. So the solution was that we want to disconnect the visual representation from their backend crafting and storage calculation. We make all the necessary data and processes persistent. So we move stuff to the backend. We put all the processing methods, the farm state variables, the managers into managers, and we put those managers into game state, which never unloads in our case because we never change the level. I will get back to that too. And storage crates, crafting stations that we build are also put in the game state, but we just create them on runtime. Every time the crafting station is built, another component is created. We use the similar class to save player data, and it's called AC statistics, and that's like I would not call it like that anymore, but it's a name that we like inherited from the other guys, and it's just sticked. And since the name is like that, then we started using that as a go-to do-all class that keeps tracks of everything, like picking up items. You have those two functions on the lower side of the screen, and it bloated, but it still works. So okay, sometimes it's okay. And all of those managers have lots of useful interface functions available from anywhere in the project, so you can access those things and make like a project that has lots of systems, but you can access those systems from anywhere in the project to run some stuff. And that's trick number 2 is decoupling and interfaces, like this get AC cinematic manager. It just delivers an actor component class. We don't want all the actors to reference all the systems, because then it becomes really hard to like manage your memory. So the best practice is to just pass parent classes like actor component, through interfaces. Then you can have all this, but without the memory bloat, and you can actually see how much memory an actor takes. And trick number 3, name your stuff like a normal person saying normal things. So we're dealing with programming language. So language is words, sentences, paragraphs, and you put that into some kind of essay, which is a game. So try to name your functions, like you can recognize it, like this crap thing. I will get back to that also, but it's just you see the name of this integer, and you know that it just tells you how many hours you need until the crap deteriorates, right? Okay, so now our data is secure, it's persistent, it's kept saved and processed in the backend, so we can save fast and easily. Good. So this is a film that I recorded just before the presentation. You will see some frame drops. I will explain that in a moment. And those yellow lines just divide the cells, the partitions. So as you can see, I can just ride around. And when I enter the partition, the new partition, the things in that partition load. When I change the partition, another piece of the map appears, and there is this crafting station that it has crafting in that station. The inventory is there, the animals with their like names and everything, they just respawn, and when I move away, they will be destroyed. So the drops, we're dealing with the drops right now because like the spawning of the actor is expensive, because those actors have lots of static meshes, and they are nanite, and like it's something that nobody tells you about. Spawning nanite meshes is expensive. So this is the front end, but how do the crafting station in question knows, or the chest knows, which backend component it should connect to? Because potentially we can have dozens or hundreds of those crafting stations and storages. We need some key and some methods to just connect them. So the middleman is like the key concept, and it's not really a class, it's just a concept that I utilize throughout the project. So the middleman is like this example, AC crafting component middleman. It sits in this crafting table, and one or more can be put into various construction objects. And when the middleman is initialized, it checks it's this number 1. It checks on number 2 if a crafting component with my index and with my GUID, which is the key, and I will get back to that also, is already created somewhere. If it is created already, just get the ref, just save the ref to the crafting component, and like pass some animation actors references so that crafting component can access the crafting animations, like the hammer hitting some nail directly. And if I'm not found, this is number 4, create something that must be created using me, the middleman. And like crafting station index is not the crafting station ID. The crafting station ID is the key, but crafting station index is that if you have like several crafting stations in one construction object, they each has to have their own index, because it's like index 0, 1, 2, 3, so they don't get mixed up within the construction object. So this is like the graph I draw for this thing is just the same as on the previous screen, but schematic. So when does it happen? When it asks that question, when it's completed, basically, when it's supposed to start working, and it doesn't happen when you just like put it on stage first, because then it's just a ghost you move around where you want to position your building, and that's not the right moment. But when you finish that and you want the crafting to like start on, or when you like respawn the object, then it's the right moment. And that's another trick. Use interfaces to find your components. So you have your parent class, the construction object, which should have some functionalities connecting the middleman, everything. But you don't put your middleman, your components in the parent class, because they have some references to other stuff. So you don't want to bloat the parent class, but you can put it in the child classes and still look for that component in the parent class using the interface, using the get components by interface function, which is neat. So the middleman is there, and it like created or got reference to the backend persistent crafting component. And when you interact with that object, you just get the saved ref to the backend component, and you interact with that. So what I'm doing, if I want to interact with this thing, then I just press interact. But what this thing does is just tells the computer over there that I'm interacting with that. It just passes my my question and opens some UI or something like that. You can do this validated get with right mouse button click. It's like I've seen it so many times on the conferences. I wanted it to be like my piece of trivia also. So yeah, there you go. So this is the interaction, and let's think about something like watering your plants. How do you, because you water the plants, and the plants are more hydrated, and the UI shows that, right? You're pouring water on the plant. So the interaction schematic is a little weird, because we pour the water on the plant actor, but the middleman tells the manager that okay, this guy is adding water. So the farming manager is calculating like, okay, this is the max, not max. Okay, we get some bonus effects, and then it passes that calculated data back to the plant actor. And you can ask, why so serious? Why don't just water the plant, and like so the plant like tells the plant itself, okay, I'm being watered, I do my own calculations, and then I pass to the manager. Wouldn't that be easier? Well, yes, it's a nice shortcut, but also it's some trouble that I got myself into. I just started doing these shortcuts because I wanted to, because why should I bother? It's just, like, let's do it faster. Well, no, if you come up with a design pattern, stick with it. Even if the shortcut seems cheaper, better, or easier, it just breaks your, I don't know, concentration, I guess. And if you don't comment it really well, then you will quickly forget which one is the shortcut and which one is the pattern. And the reason why it's not going to work here is because, well, the farm unloads, right? And we have farm hands, employees of the farm, and they will want to water your plants also. And it will happen in the back end. So like doing any operation on an actor is a wrong thing to do, because some of the times the actor will not even be there. So we have to do all the operations in the back end. And when the actor respawns, it will just pull the data and synchronize. And yeah, use shortcuts only when optimizing, and comment them extensively. This is great if you have some some overhead that you have, and then you have to optimize. Then use some shortcuts. Then comment that, and it's gonna be great. So to sum it up, middleman is a link between front-end object and which visualizes the crafting station, and the backend component, the persistent one that does all the work. But the second thing is that it keeps the component's definition. So it's easily editable by the designer. So you have this crafting station something something, like a kitchen. And it's just a bunch of data in the middleman, and you want that kitchen to be a forge from now on. You just change the enum to forge, and then the kitchen is spawned, and then it spawns a forge component, right? And suddenly you have a forge kitchen. And there is another thing. It's not a feature, but it's just nice thing to have because a middleman connects to a like backend component, and that backend component like can be pointed to by several middlemen. So you can like this is a job or a mail, and you can like deliver stuff that has been ordered from you through the mailbox or through the delivery card, or just go to the character and talk to him. Okay, so we need the key, and that's the funny part. We need to key to find the proper backend component because we have the methods to find it, and we need just a key. It can be anything unique that comes in large quantities, like integers. And we use it for plants, crafting stations, mail, storage, because they are all added in runtime, so we can keep track on that. But how about items placed on the level by the designer? Like all the construction objects, all the decorations, the items, everything. So they can be, hundreds of them, and it would be really inconvenient to use a unique integer for each one. So we need something that is unique with each generation and has unlimited combinations. And if we only had this key, we would truly have the unlimited power. And there is such key. It's called GUID. And does anybody know how to pronounce it like properly? Because I could not find any like person in English speaker trying to pronounce GUID. Yeah, but it's like GUID. I prefer GUID, so okay, let's stick with GUID. So GUID is globally unique identifier. It says something like that when you just like put your mouse on the dot. It's a struct, but you cannot break it. It lacks any documentation. Looks like that. Has impossibly small chance of repeating itself with being like generated twice with the same. Can be saved to a variable and can be serialized. It has some really cool features, like you can compare them, you can invalidate them, you can generate them easily. And every actor on the level already has a GUID, which is great. And I was like, damn! It was everything that I actually needed to make my system work, but it had a fundamental flaw. It didn't work. Well, it turns out that it gets invalidated during the cooking process. And all the GUIDs of my construction objects were just giving me 0, 0, 0, 0, 0, 0. So then I was like, the horror. The horror. So, what to do? Well, the solution was very simple. I made my own GUIDs. Because they can be saved to a variable. So I started putting GUIDs on so many things, like farm bounds, like this manage something, master item GUID. Everything had its own GUID, and I finally reached the unlimited power. So how does the respawning process work? Well, let's use a construction object as an example. When it's an editor-placed object, so it's an object placed on the level by an editor, by designer. It loads when the level loads, and then it registers itself to a farming manager, and then it destroys itself. If it was registered before, it checks if that GUID is already there as a registered object. And then if it is, then it destroys itself because the data is already on the persistent manager. Runtime placed object is spawned by the player when selecting object to construct. So like this little ghost. It does nothing because the construction process can still be cancelled, but when it is confirmed, then it goes into this under construction state, and then it registers itself in Farming Manager. And you have several things in here. Like number one, generate new construction object GUID, which is weird. It could be this generate new GUID function here, but you know, with so much time and budget constraints, sometimes it's hard to, like, you know, okay, I know I can do it better right now. Maybe I should redo the stuff that is still working and I can do it better. No, I need more functionalities, new stuff. Parent GUID is important because sometimes construction objects have like children. So you build a workshop and then there is a work table in that workshop, and that table needs to know when you want to deconstruct the workshop. So it's parent GUID. And you can, under number 3, you have owner farm bounds GUID, and that's the farm bounds. We will talk about that later. So runtime respawn object gets respawned by the game systems, try to register into farm bounds. If successful, it synchronizes the state with the manager, meaning it downloads all the data and apply the construction state, the module completions, decorations, and everything. But what if it's unsuccessful? We'll back to them later. So now we can construct objects and write their data to the manager where it's stored safely, and we can happily wander out into the great outdoors because when World Partition unloads them, we have the means to respawn and sync them again. No. Because how the World Partition works, that's some quotations from the Unreal Engine documentation. World Partition can be switched off for some actors by setting spatially loaded to false, and then the actor becomes something that was in the early access Unreal Engine 5 called always loaded. And it's just always loaded on the level. But how does it also work? Well, it leaves the runtime spawned objects alone. So their lifetime, their life cycle is not managed by anything. So when you spawn an object in runtime, unless you deliberately destroy it, it will just, you know, stay there. Which means that if you have specially loaded landscape and runtime spawned actors with gravity, they may fall down, you know, below the map and get killed by some Z killer thing you have. So then our farm will never unload, right? Because we create the farm and it's a runtime created actor and it will never despawn, and like our system is not going to work. Is it a fundamental flaw again? Because we need those farms to unload, because there are draw calls and animals, and this is the whole idea that we want to like despawn it. So we need a spatially loaded probe that will, god damn, it's 32 minutes. Whoa, perfect. We need a specially loaded probe because, yeah, we are creative. We just want to have those things unloading, and we just need to tell them to unload because we can do that. So we have farm bounds. Every green box you can see here is an actor called farm bounds, and they are spatially loaded. They are put on the map by the designer. And the farm bounds initial like reason for them to be there is just a volume defining where is the construction and farming area. Because if you try that outside, you will get this, you can build stuff only on the land, you own prompt. So we can build outside, and they are placed by the designer. I said that. And this graph, how is it possible for the respawned object to fail to find farm bounds if it's impossible to build anything outside farm bounds, right? Well, because it's not the farm bounds that respawn construction objects, it's the farming manager. Why? When the partition gets loaded, all the actors on that partition get loaded on that very frame. So, and they fire begin play, and they they would start spawning actors, and that may become, you know, a choke point, because like on the first example that I showed you, the cells were really small. They had like, I don't know, like 16 meters on each side, but in our game they are way larger. So most of those green boxes you've seen there would load in the very same frame, and they start spawning actors, and that could be, you know, a choke point. So what the farm bounds does is that it fires begin play and then asks the farming manager to respawn their construction objects, giving the GUID, like you have a list of all construction objects, and they have the farm bounds GUID somewhere there in the data. So now go and respawn only those on my GUID thing. But it respawns the farming actors, the fields itself, because they are very simple actors. So they can be spawned instantaneous without, they don't have the nanite static meshes. So what does the AC farming manager does? It finds the construction objects registered to the farm bounds by their GUID, populates the struct with transform, GUID object soft class and initial state, and calls async load. And I wanted, yeah, you have this, doesn't work, I guess. Okay, here, this thing is a GUID, it's a struct, and this thing is also blue, it's an object class, but it just like, it's not really a class. I'm gonna get back to that also. So async loading spawns it one by one like a gun, and it's a neat thing to like, how many of you doesn't know what async load is? All right, perfect. So like 2 people. So you can keep your class as a hard reference in your blueprint and just spawn it right away, but it makes that class reference the other class, and it's, you know, heavy. It's not really a good practice. So you have soft classes, and you can load them when you need them, and this is way better. So what it does is it adds the construction objects, this little struct, into an array, and then calls like start spawning, like number 1. So it starts spawning. It checks if it's spawning anything at the moment at number 2. Then checks if there is a valid object to spawn next. Then, you know, async loads them, spawns the object, then removes the first the 0 index and calls another object to spawn. So then you just fire like a gun, like each bullet is one object, and then you can load the magazine from the below. So until everything is loaded, then it's just gonna keep firing. And it's easy to optimize that, because if you find that, okay, spawning like 60 objects in one frame, because, you know, first few will get async loaded, and then they will just keep loading because they're in the memory, then okay, it's bad. So you can just add a delay about, or somewhere around number 4, and you can give it some more, you know, thought. So like every 10 generations, it will just have a break for a frame or 2 or something like that. Okay, then there's this star. It's a 2 soft class reference. I think I will get back to that later. Yeah, that's this one, trick number 5, soft class path. So it's basically a string, and it's crazy when I learned about it. You can break down the soft class path even more, and like make it a string, and then you can like save that string using like basic data, which is neat. And you can do crazy stuff with that, like save references to static meshes that are somewhere in your project using a string, and then like find the static mesh, which is crazy. You can make keys out of that string. But those are quite easy to break, and you can't validate a string, right? So it has some limitations, but it's a fun thing to explore. Yeah, so this is something that I already said. Yeah, so why can the construction object fail to find its farm bounds when it gets spawned? Well, because it can no longer be there. Like, this is the moment where like World Partition would load you guys, and this is the part when I'm loaded, and I could do it just like, whoosh, and you get loaded, and you are spawned, but then I move away, and the farm bounds there just disappear, and then some of you get spawned, and there are no farm bounds anymore. So it's just like a guard for this kind of situation where farm bounds disappear, like appear and disappear very fast, and then we have to destroy that building. So the uncomfortable conclusion to all I said is that construction objects are not spatially loaded. Our plants aren't spatially loaded either. So why, like, they don't use word partition at all. Why? Because they are complicated static mesh component heavy objects. And I'm talking about like 250 static mesh components in a single building, broken down into many scene components that make the construction object. And it's expensive to spawn a nanite object like that, and we are struggling with like working on that at the moment to just make it like more performant. But then even if it's more performant, then why would you want to have many editor placed objects appearing in your game all the time, while they all are kept in the manager already? So we can just make them appear just one time on the very start of the game and like register themselves and disappear. And it's better to just load and unload them through our custom manager that have the bunch of actors like that load in and out all the time. And so why all the hassle with World Partition? If we still have to do our own custom methods? Well, it's still a great streaming manager for static meshes, foliage, simple level actors, like lots of deserts, rocks and everything, and it still works great. And actually it still gets the job done, but we need the intermediary in the form of farm bounds. The one file per actor system, it's great, but it it's tricky with perfors. At least we are experiencing weird behavior, and that's a pro tip that cost us weeks, I guess, of development. If you're struggling with hard to explain FPS drops when your cells load and unload, it's most likely foliage, and it's most likely collision when like thousands of actors load. They will try to calculate their overlaps, their collision, and if foliage is thousands of actors, so they will like appear and then they will calculate that. So go through your foliage one by one and eliminate all collision and all the like spheres, everything. It will work. And also, this is a trick that we use all the time. Organize your level using location actors with gameplay tags or any other like things you use to organize your stuff. And then you can add World Partition streaming source. And World Partition streaming source is the thing that makes World Partition work, and it's on the player pawn. When the player pawn moves, the streaming source moves, and that's the thing that informs World Partition to load something. And then you can have a function like that: load the level around the location by that gameplay tag, and then you enable that World Partition streaming source, and bam, the level around somewhere else when you're not there gets loaded, and you can like quickly fast travel to that place or show a camera view of that part of the map. So a few more words about everything else, because that was the hardest part, and we have other stuff like pickables. They are spatially loaded because they're lightweight, usually 1-2 meshes, and when they are loaded, they just check if they have been picked up. If so, destroy. If not just stick there, and when you pick up that object, you just mark the object as picked up in AC statistics, the bloated function, the manager. Characters, activities. If you ever played Stardew Valley, you know that they just move around the map and like do some animations basically. So all of those things are events. And those events, like most other things in the projects, are just a bunch of data structs. So each character's calendar sits in that character's calendar manager, and those sit in calendar manager actor. And we basically save those tracks, add some events on runtime, and they're easily savable. And then when we approached a location where that actor should be, we just evaluate that actor, and that actor appears like there, is spawned there, because we don't care if like a shopkeeper is, you know, like standing behind the counter or examining some shelf or cleaning or smoking a cigarette. He's there. That's all we need. And we use RTC Draft to manage the narrative, and I would say it works great. And I tried saving the objects, but it didn't work. But then I tried saving the database itself, and there's no functionalities like that either. But then from each object that you have, like, I don't know, a quest, a journal entry, some objective, it's usually just a little data that you need to save. Like if the quest has been revealed, or if it has been completed, or how many objects, how many stones did you pick when completing some task or objective. So there's not much to save, and we use the technical name of the object, which is unique, and write it to maps. And then when loading the game, we just use the normal function that we use when this one, when we complete some quest or task, but with the feedback set to false, and then it just, you know, does what it usually does, but without the bam bam bam, you finish the quest prompt. And this is actually very important, because so many things in Cowboy depends on the narrative. And that's why we have the wait until the game is loaded macro, and it's just everywhere there, and this random delay prevents all the actor proceeding with doing their stuff when the game finally loads. Okay, so saving the game is super easy. It's serializing and saving, and this is, you know, the easy part, and this is on the only CPP part in the entire framework. And at the same time, it doesn't require any CPP knowledge, because it's an easy multi-save marketplace plugin. And yeah, we just inherited that with the rest of the project, and they were using that to save the actors in this so-called like actor-oriented like framework. But we had time constraints and budget constraints, so we just decided to stick with it. And all it does, it simply serializes and saves the data into a save slot, something you can easily do with normal Unreal solution. But it just has this neat pre-save event before, which is useful, because then we can parse all the data to abstracts from the components before we save the game. And can it be done without easy multi-save? Of course. You just, you know, do an interface, add that interface to actors you want or components you need to save, and then just call the function you need. And that's basically what EMS is doing, and it's written in their documentation. So one more thing that I forgot to add. Yeah, we have one level, and the level starts when you start the game. It's just the single level. There is no like menu level, and when the game starts, it just checks what was the last used save slot, and then loads it. So when you start the game, you arrive at your own farm. You can hide the menu to just, you know, enjoy the view. Every like animal, every object is respawned and ready to use. And when you click continue, just appear instantaneously. There is no loading after that. And this is something that I already said. And this is interesting. Like the event on post login is one of the first events that is fired in game mode, and you can add option string, and the option string is this options thing when you open level by name, and we use it to like restart the game. And number two, like when the game starts, it checks the last used, most recent used EMS save, and if if it finds it, then it loads the game right away. And when we want to reset the game, then we fire the open level by name with restart to new game option, and then it will just, you know, make another game and make another slot, and then you can switch slots. But when you switch slots, you just reload the level. Challenges and more tips. We're getting to the end. Proper order. This is very challenging. Like with a system like that, it's a lot work to just make everything appear on the right time, because you have decorations that's like, it's like items you can put anywhere. They need to find an object that they reference, or the object has to spawn them, and what do they do after that. So if you plan to deliver a safe system and you think like, okay, that's gonna be a week, okay, think 3 weeks. If you think it's gonna be in a month, think like 2 months or 3 months, because it's gonna be super challenging to like come up with all the edge cases. Yeah, and color code your comments. Like pink ones is me. I'm Mr. Pink. The risk, alt drag risk. Level designers usually do the alt drag thingy, but if you do that and you have some GUID in that, you will alt drag this GUID also. So suddenly you have two objects that have the same GUID, and that's a bug. And what you do is you just add this piece of code on the construction script, and when you hit the decoration actor GUID generated on the details, it will just regenerate the GUID, and it will be a new one. And also it's very important when you move into like a production ready game, that when you start messing with stuff that was already put on the stage, it may break the save game of people that were using that, because the GUIDs start to get mixed up. So this is something that you want to have in mind. Datetime plus time span. This is great if you're doing anything that is crafting related or time related. Date time plus time span is like no-brainer. It's great. You can add time span to a date or another time span, and you can have 28th of February and then add 3 days, and it will come with, you know, 2nd of March, which is great, and it takes into consideration all the, you know, calendar weird stuff. Collect your garbage. This is funny. I learned that like a month ago. When unloaded by World Partition, actors keep their state until garbage collected. So you move into a cell, then move out, and that actor disappears. It just destroyed, removed from the world. It says something like that on the end play. But when you move back fast enough, it will keep their state from before being destroyed, which is crazy. And if you wait 60 seconds or more, it will be garbage collected. But if you want to like reset your level, just disabling the level streaming actor, like the component I told you, and then re-enabling that, just be careful to collect your garbage in the process. Done.